Hello aspirants, today we are going to start a new topic, that is calendars. And calendar is a very common topic in most of the competitive exams. If we talk about law, we have CLAT, we have CET, that is symbiosis entrance test, we have other law entrance examination. If we talk about bank, we have bank POs, we have clerical, we have insurance. If we talk about MBA entrance exam, we have SNAP, symbiosis aptitude test, we have IFT, we have NMAT, we have CMAT, we have MAT, we have MHCET. So calendar generally comes in that paper where speed do matters, because the number of questions are almost 100, 150 to 200, where a person has to spend almost 30 to 40 seconds on a question. If he spends more than a minute, for him he's out of the race. So calendar is a topic which comes in a paper where speed do matters. But now, to solve calendars, you should need some in-depth knowledge regarding calendars, the terms, the terminologies that are very much important. Now calendar, if we talk about subject as a logical reasoning, calendar can be asked in two ways. That is, the first way is the actual calendar, the original calendar which we follow, that is the universal civil calendar, most of the countries do follow. And the second is comparative calendar. Now comparative calendar is a calendar where you have to compare between two dates. So we'll go with actual calendar, because here the important aspects are there, like the terminologies, the technical aspects. And after going through the actual calendar, we'll go with the comparative calendar. Now as we know, actual calendar, the calendar which we follow, that is the universal, the world follows, that is the civil calendar, that known as Gregorian calendar. Now Gregorian calendar is a calendar which is followed after the Julian calendar. Earlier we used to have Julian calendar, but Julian calendar had some technical glitch in them, so we adopted Gregorian calendar in the 15th century. And if we talk about Julian calendar, now calendar is not a natural phenomena, it is made by some statisticians and it is based on numbers. Now earlier we used to follow Julian calendar, where the calendar had some technical glitch regarding leap year. Now in 15th century we rectified that problem, we made a different solution to it, and then we came up with a Gregorian calendar. Now two things in calendar one should remember, that is the leap year, because of which the calendar was changed, and the second is the odd days. Now we'll have explanation of both. First we'll start with leap year. Now the basic difference from Julian to Gregorian was the leap year, because in Julian calendar every fourth year was a leap year. Coming to Gregorian, what they did in Gregorian, they changed the pattern. They divided leap year in two parts. One leap year which comes in a normal year, second leap year which comes in a century year. Now leap year which comes in a multiple of 100 were considered as century years, they were treated differently, and the other year like 4, 8, 12, they were treated differently. In Julian, every year, every fourth year was a leap year. So what happened in Julian? Like we take an example, fourth was a leap year, we had 8, 12, 16, 20, 24, so on till 80, 84, 88, 92, 96, 100, 104, 108. So year 100 came as a leap year, but in Gregorian they divided in two parts. The normal year, that is 4, 8, 12, 16, so on till 80, 84, 88, 92, 96. Now year 100 was not considered, because 100 was part of the different group, that is the century year group. So next leap year was 104. Century year, like in normal year every fourth year was a leap year, in century year again every fourth century year was a leap year. So 100 was not a leap year, 200 was not a leap year, 300 was not a leap year, 400 you had the first leap year. So in Gregorian calendar, what basic changes was done, that leap year was divided in two groups, that is a normal year leap year and the century year leap year. In Julian, every fourth year was a leap year, so most century years was divided by 4, so that became a leap year. Now what was the basic difference that occurred in Julian and Gregorian calendar? In Julian calendar, let's take an example of Easter. Now if today was Easter, but on paper, like on calendar, 3 days before Easter was used to come. Every day, every festive season used to be coming on paper 3 days before than the actual date. Now in Gregorian that was rectified, and how that it was rectified we'll go and we'll see that in further cases. Now in Gregorian calendar the leap year was distinguished as leap year in normal year and leap year in century year. Now every fourth year was a leap year, so whatever the year, that is 1904, 1996, you had 2016, you have 2022, so these are the normal year, and it comes every fourth year will be a leap year. So the last two digit, if it is divisible by 4, that means that year is a leap year. So this is divisible by 4, this is divisible by 4, this is divisible by 4. 2022 is not divisible by 4. So in normal year, the last two digit, if it is divisible by 4, that means that year is a leap year. If it does not, that year is not a leap year. And what happens in a leap year and non-leap year? A leap year consists of 366 days, where there is one day extra in Feb, that makes 29th of Feb. In non-leap year, you have 365 days. Now in century years, like we'll get years like 1900, 2000, 2100, 1500, 1700. Now in century year, the group of century year, every fourth century year was a leap year. So for century year, we'll have to divide the whole year by 400, and if it is divisible by 400, that means that year is a leap year. So if 1900 is not divisible, this is not a leap year. You have 2000 as a leap year, 1500 is again not a leap year, 2100 is again not a leap year, 1700 is not divisible by 400, so it is not a leap year. So that difference, if you want to find a leap year, last two digits should be divisible by 4 in terms of normal year, and in terms of century year, the whole year should be divisible by 400. As I said, that calendar comes with a paper which depends on speed, so you need to have some short tricks, but short tricks comes with some understanding. Simply mugging up that tricks won't be helpful, so we'll see the short trick with a detailed explanation. Now to make things easy, we have to find odd days. Now whole calendar depends on odd days. Now what are odd days? So like in school we used to study find the odd one out. That means we have been given 5 or 6 variables, and all variables used to have some common characteristics apart from one, and that variable used to be an odd one out. Same strategy is used in calendar. Like odd days, that means number of days are converted into weeks. The extra days which does not make a week are called odd days. For example, if we have 20 days, now 20 days, that means we have 7 days a week, 7, 7, 14. Now from 14 days we can make 2 weeks, remaining 6 days. Now this 6 days does not make a week, so odd day in 20 days is 6. Coming to 50, we have 7 sevens are 49, and we have 1 day extra, that cannot make a week. So in 50 days there is one odd day. So to find odd days, you have to divide 7 and the remainder, that is the odd day, because you have to convert the days into weeks. Extra days that does not make a week is odd day. So it's easy to remember is to divide it by 7 and the remainder is the odd days. Now if we talk about leap year, leap year has 366 days, that means it will have 52 weeks and 2 extra days. That means in a leap year, in any leap year, the number of odd days is 2. For non-leap year, again we have 52 weeks and there is 1 extra day, that does not make a week. So any non-leap year, there is only 1 odd day. Now with this we'll make a table that will be very easy for us. So if we talk about first 100 years, now first 100 years, I'm talking about years, that means it will consist leap year as well as non-leap year. So according to Gregorian calendar, first 100 years we have 4 as a leap year, we have 8 as a leap year, we have 12 as a leap year, we have 16, we have 20, and so if we go, we have 92, 96, 100. But in Gregorian calendar, the 4th century year was the first century year with a leap year. So 100 was not a leap year because it is not divided by 400. So from 4 to 96 we have 24 leap year. Now from 100, if we have 24 leap years, that rest 76 we have non-leap years. Now if a leap year consists of 2 odd days, so there are 24 leap year, each leap year consists of 2 odd days, so that will make 48 odd days. For every non-leap year there is 1 odd day, so we have 76 non-leap year, that makes 76. So 48 plus 76, that makes 124. Now one thing to remember, that whatever be your odd days, that should be between 0 to 6. If it exceeds more than 6, that is divisible by 7. So answer of odd days should always be from 0 to 6. If where it goes beyond 6, it is divisible by 7. Now here if we have 124 odd days, That means that is because we have considered leap year and non-leap year differently. So this 124 days will also be converted into weeks. That is 7 ones are 7, we have 7 sevens are 49, so we can have 17 weeks from this 124 days, and we have rest 5 odd days. As now if we look it as a journey from 0 to 100, as 100 was not a leap year, so there were 124 odd days, that was total 5 odd days. So if we talk about 200, that is from 101 to 200, again there is 100 years, again 200 is not divisible by 400, that means this 100 years is not having a century year with a leap year, that means it will go in a same trend with 100 years, that is from 101 to 200 we have 24 leap years, we have 76 non-leap years, which will give 124, the final will be 5 odd days. So from 101 to 200 the total odd days are 5. But if we talk about the first 200 years, we have 5 in first, we have 5 in second, that makes 10 odd days. 10 odd days, we can have 1 week, that means remaining 3 odd days. So if we count it like this, first 100 years that will be 5 odd days, but first 200 years that will be 3 odd days. Now if we take a journey from 201 to 300, again 300 is not divisible by 400, that means again the same trend from 201 to 300 we have 5 odd days, because 300 the century year was not a leap year. But if someone says that first 300 of the year will have 5 plus 5 plus 5, that makes 15, 15 that means 2 weeks, 7 2s are 14 and 1 odd day, that means the first 300 years of the calendar will have 1 odd day. Again for 400, now from 301 to 400, now here in this 100 year the century year is divisible by 400, that means here there will be a leap year in case of century year, as 100 with a century year as non-leap year was 124, but here the century year is a leap year, that means it will be 125. So 125, the final odd days will be 6. But if someone says the first 400 years we have 5, we have 5 10, we have 15, 15 and 6 21, 21 makes 7 3s are 21, so we have 0 odd days. So first 400 years will be 0 odd days. Now as we have found the first century year as a leap year, from there onwards 500 will again be 5, 600 will be 3, 700 will be 1, 800 will be 0. So the cycle repeats every 4th century year. Now as we have discussed the topic, we have to remember this term, that is every leap year will have 2 odd days, every non-leap year will have 1 odd day, first 100 years will have 5 odd days, first 200 years will have 3, 300 will have 1 and 400 will have 0. Now why we discuss it rather than mugging up, because there was a case in 2012 in Symbiosis Snap paper, the question was how many odd days were there in 100 years. Now the question says how many odd days are there in 100 years, that means which 100 years, we don't know the span of the 100 years. This is a particular 100 year, that is the first 100 years. So in the first 100 years we have 5 odd days, but any random 100 year, as we do not know the span of that 100 year, so that will be cannot be determined. So if mugging up will make an chaos, let's suppose in paper it comes that how many odd days are there in 200 years, we have mugged up that in 200 years there is 3 odd days, so we'll mark as 3, but that is wrong because it says 200 years, which 200 we do not know. This is a specific first 200 years, that's why it is 3. So these two tables are very much important. Secondly, a leap year is distinguished in 2 ways, that is in normal year last 2 digit is divisible by 4, in century year the whole value is divided by 400, and odd days, that is we have to divide by 7 and the remainder is odd days, because odd days means converting the number of days into weeks, extra days which cannot make a week is odd days. By observation we can see that the difference between Julian and Gregorian calendar, as Julian calendar did not had a differentiation between century year leap year and normal year leap year, so 100 as there will be 6 odd days, for 200 there will be 6 odd days, for 300 there will be 6 odd days, for 400 there will be 6 odd days. So 406, 406, that's fine. 106 here we have 100 as 5, 206, here we have 200 as 5, 306, here we have 300 as 5. So the extra one day in all the first 3 century years, that made the difference. As I said earlier, that let's suppose that today is Easter, but on calendar it used to be 3 days before. So that 3 days was this one, and this one day. So every century year there used to be an increase of a day. That makes a difference of 3 between actual on the calendar. So this was the difference in Julian. So that's why it was changed to Gregorian calendars with some minor changes. Now we'll go with a question. So we'll just take a recap. That is, every leap year will have 2 odd days. Every non-leap year will have 1 odd day. First 100 years, that is 5 odd days. First 200 years, 3 odd days. First 300 we have 1 odd day, and first 400 we have 0. Now we'll take an example. 15th August 1947. So which day it was? So now as we see, the year is 1947 and the month is August. That means if we see 1947 is a running year, it is not completed. So we'll go 1 year back, that is 1946. As till 1946 each year has been completed. As I said, that calendar is dependent on odd days, so we have to calculate odd days from the first year to 1947. So we'll go with the help of this this table. That is the short trick for us. So it is a multiple of 100. We have 1946, which is not a multiple of 100, so we'll make a multiple of 100. 1900 plus 46. Now we have the table. That is, the first step is 1900. Now as after every 4th century year the cycle repeats, that means 500 will be 5, 600 will be 3, 700 will be 1, 800 will be 0. So we have a base of 400. Now we'll take a multiple of 400, which is close to 1900. That makes 1600. We cannot take 2000 because it does not imply that we should go ahead in future and come back. That will be very difficult and that is impossible. So we have 1600. So in 400, if it is 0, so every multiple of 400 will be 0. So 1600 will also have 0 odd days remaining. If we subtract 1900 and 1600, we have 300, and in 300 we have 1 odd day. So in total 1900 we have 1 odd day. That means this table has helped us in directly calculating odd days from 1st to 1900 and automatically divided it by 7. Now as we have reached 1900, the next step is this 46. That means it is from 1901 to 1946, because in first step we have completed 1900. Now in 46 we can see the number of leap year. So in 46, if we have to check the leap year, we have 46 years. 4 ones are 4, we have 6, 4 ones are 4 point. Now we have 11 leap years. So in 46, if there are 11 leap years, rest 35 will be non-leap year. In this process we can have 2 approaches. The first approach is very manual. Now in every leap year there are 2 odd days. We have 11 leap year, that means 22. Every non-leap year we have 1 odd day, so in 35 that will be 35. So the total will be 57. This is one approach. And the other, which is very easy, 46 has 11 leap years, so we'll add 46 and 11, that will also make 57. So the both approach are legal, both approach are valid, so you can use any of them. This will be much easier because we do not have to calculate and add, because if there is an error in a calculation it will give wrong output. Also it is a time taking. So see, simple way. Now let's take another example. If we have 72, so this 72 have some 4 ones are 4, we have 4 8s are 32, so we have 18, so we'll add 18, we'll get the odd days. So same, we'll take the leap year and we'll add. So because in this 46 we have leap year one time and we have non-leap year one time, we have to add one more leap year to make it twice in 2:1 ratio. So we'll directly use the short trick. So we have reached 1946, that is 57 odd days. Now the final step, that is 47th year, because we cannot consider 47 as a whole because it is a running year. We have completed till 15th August, so we'll go month wise. So we'll go month wise because 47th is a running year and the date is of 15th August, so it is not completed yet. So we'll go month wise. The first month is January, which have 31 days. All 31 days have been completed, so that will be 7 4s are 28. 28 minus 31, we have 3 odd days. Next comes Feb. Now, no, 1947 is not a leap year, so Feb will have 28 days. It will be 0. Then again, March 31 will divide it by 7. 7 4s are 28. Difference of 28 and 31 will be 3. Then we have April, that is of 30. 7 4s are 28. Difference will be 2. May 31, 3. Now, whenever there is 31 days, we'll have 3 odd days. For 30, we'll have 2. For 29, we'll have 1. For 20, we'll have 0. Now, after May, we have June, which have 2. July, 3. August will also have 3, but August we have completed. We want the date of 15, so we'll consider till 15 only. So for 15 we have 7 2s of 14, 1 odd day. So if we add this, we have 3 3 6 3 9 3 12 14 16 and 1 17. So in the third step the odd days is 17. Now 57, 17 and 1, if we add this, we have 75 odd days. Now as I said, the odd days should be somewhere from 0 to 6. This 75, because we have calculated it in 3 different steps, so we'll again divide it by 7. 7 tens are 70. We have 5 odd days, so this 5 is an answer. Let's see the answer. If it is to be 0, then it will be Sunday. If it is 1, then it will be Monday. If it is 2, it will be Tuesday. If it is 3, we have Wednesday. 4, we have Thursday. 5, we have Friday. And 6, we have Saturday. So 15th of August gives a remainder of 5, that is odd days of 5, so 5 is Friday. So 15th of August 1947 was Friday. Now as it looks like a lengthy process, now we'll take an example and we'll solve it in the same approach, and we'll see if we can complete it between 30 to 45 seconds. We have 23rd of November 1988. So which day was 23rd of November 1988? So first step, we have to go back, that is 1987. So we will split 1900 plus 87. We have the first step as 1900. Now 1600, that will give 0. We have 300, that will give 1. So the total odd days in 1900 is 1. Coming to 87, if we check number of leap years in 87, that is 21. So in 87, if we add 21, we'll have 108. Coming to third step, we'll go from 1st of Jan to 23rd November. So we have January 3, we have Feb, as it is a leap year, it will be 1. We have March, April, May, June, July, August, September, October, and for November we have 23. 7 3s are 21. We have 2. So that makes 3 3 6 3 9 3 12 15 18 20 22 24 26 27. So 27, we have 108, 1 and 27. So that makes 136, and if we divide by 7, we have 7 1s are 7, 7 9s are 63. The remainder is 3. Now 3 is Wednesday. So 23rd November was Wednesday. Now this, as we know the approach, or we know the concept, or we have the in-depth of the short trick, so it makes very easy and very fast. So this was the Gregorian calendar. Now we'll move to comparative calendar. Now in comparative calendar, what happens is the calendar can be actual, or it can be a superficial or a fake calendar. We have to just compare. Now earlier, what we did in Gregorian calendar, we had to go from the scratch, that is the first year, till the given date. We have to count the odd days, because we have to see the calculation. The whole calculation was made in accordingly. But in comparative, we do not have the previous data. We have just a number and we have the other number. So between two numbers we have to calculate. For example, let's see, we'll take the previous example only, that is 23rd November 1988. Now as we calculated, it was Wednesday, but according to comparative calendar, let's see, if I say that it is Saturday. Now if 23rd November is Saturday, the date will be, let's see, 1st of March 1990. 1st of March we have 1990. Which day? Now this is actually a comparative calendar. Here the previous data is not there, and we do not have to go from the scratch, that is from first year or the first day of the calendar till March 1990 we have to calculate all the odd days. In this we do not have to do that. And also like 1900, 1600 we have 205 odd days, 200 3 odd days, 300 one odd day, 400 0 odd days. 0 used to be Sunday, 1 used to be Monday. In comparative calendar we do not have to do any kind of this thing. It's just we have this as a data, whether it be true or false. We have to compare this both data according to the base. And as 0 was Sunday in Gregorian, here whatever day it is, that has to be 0. Now as we know that 23rd November was Saturday, from next day, that is 24th November till 1st of March, we'll have to calculate all the odd days and we'll consider it from 0 as Saturday. So let's calculate. Now as November, we'll make the calculation easy. So as November, from next day onwards we'll have to find. So November has 30 days, out of which we have completed 23. So the next day, that is 7 days more to go. So odd days will be 7. We have December, that will make 3 odd days, and we have done with 1988. Coming to 1989, we have a whole year. We do not need to go from month wise because it's a complete year and a complete non-leap year that will have only 1 odd day. Coming to 1990, we have 1st as January, that will make 3. We have Feb. Now 1990 was not a divisible by 4, so Feb will have 0. We have March. Now 1st of March, so odd days will be 1. So if we check, we have 10, 11 plus 3, 14 plus 1, 15. So between this, from 24 to 1st of March, we have 15 odd days. So for 15 we have 7 2s are 14, we have 1 remainder. Now if 0 is Saturday, we have 1 as Sunday. That means 1st of March 1990 was Sunday. So this is a basic example of a comparative calendar. Now coming to questions of comparative calendar, in any of the competitive exam, let's take an example. I will give you an example of a question I have faced competitive exam, that is, if 15th of March was Wednesday, then 20th November of the same year falls on which day? Now in this question the year is irrelevant because it is the same year, the both dates are of the same year and it is after Feb, so the year is irrelevant because we do not need, or there is no necessity of leap year. Now as we know, 15th of March was Wednesday, so Wednesday will be 0, and from the next day of March, that is 16th of March till 20th November, we'll have to take the odd days. Now March has 31 days, out of which 15 are completed, so we have 16 days, that will make 16. So 2 odd days, 7 2s are 14, 14 and 16 difference is 2. We have April, that is 2, May 31, June 32, July 31 3, August 31 3, September 32, October 31 3, November 20th, that makes 7 2s are 14, that is 6. Now 2 to 4 to 6 to 8, 8 and 6 14, 17, 20, 23 and 26. So we have 26 odd days, and if we divide it by 7, we have 7 3s are 21, odd days is 5. Now if 0 was Wednesday, we have 1 as Thursday, 2 as Friday, 3 as Saturday, 4 as Sunday, 5 as Monday. That means 20th November was Monday. So this type of questions are of comparative calendar. We'll take one more example with a year, so things will get more clear. If 30th September 1995 was Friday, then 1st of Jan 2001 is which day? So we'll keep Friday as 0. Now as we know 30th September was Friday, we'll go the next day, that is 1st of October. October has 31 days, we'll give 3 odd days. We have November, we have December. So here we'll complete 95. Now coming to 96, it's a leap year. It's a leap year, a complete leap year will give 2 odd days. We have 97 with 1, we have 98 with 1, we have 99 with 1, we have 2000 with 2. Coming to 2001, we have 1st of Jan, so we'll come with this odd days, so we'll add this, that makes 3, 3, 6 and 2, 8, 8, 10, 11, 12, 13, 14, 15 and 16. Now if 16 is divided by 7, we have 2 odd days. If 0 is Friday, we have Saturday and Sunday. So 1st of Jan 2001 will be Sunday. Now finally, after comparing after going through both the type of calendars, we'll have some miscellaneous type of questions. Like if I say the first day of a year was Tuesday, then how many Tuesdays will be there in that year? Now this type of miscellaneous question do come in paper of mostly in symbiosis or MHCT or CMAT. Even in campus, we can see in campus questions from AMCAT or any campus recruitment drive, we have questions of calendar. Many times I have observed that. So if it says that the first day of a year was Tuesday, then how many Tuesdays will be there in that year? Now we'll see the approach for this. The first day, that means 1st of Jan. Now let's assume the first week of a year, that is from 1st of Jan to 7th of Jan. If the first day was Tuesday, 1, 2, 3, 4, 5, 6 and 7. So 7 days a week. The first week will start on Tuesday. So last day will be Monday. Now we'll come to the second week. Second week again it will start with Tuesday. It will end with Monday. Now we have two type of calendars, that is leap year and non-leap year. Both of them have 52 weeks, but leap year has 2 extra days and non-leap year has 1 of extra day. So if we talk about first week, it starts with Tuesday, ends with Monday. Second week again it starts with Tuesday, ends with Monday. We have third week starting with Tuesday, ending with Monday. As we go further, we have 41st week starting with Tuesday, ending with Monday. We'll go somewhere further, we'll have 50th week starting with Tuesday, ending with Monday. We have 51st week starting with Tuesday, ending with Monday. We have 52nd week starting with Tuesday and ending with Monday. Now as soon as 52nd week ends with Monday, in leap year other 2 days will be Monday. After Monday there will be Tuesday and Wednesday. In non-leap year we finished after Monday, the next day will be Tuesday. Now if we look at by observation, we can see we have 52 weeks, 52 Tuesday, and in leap year we have one more Tuesday, as well as in non-leap year we have one more day, that is Tuesday. So the first day of a year in both the cases, that is leap year and non-leap year, will come 53 times. So most people I've seen they have marked option as cannot be determined because they do not know or they have confusion that the year can be either leap year or non-leap year, but the answer will be unique determined, that is 53, because in both the cases we'll complete 52 weeks and we'll have the next day, that is both the days have at least one day remaining, one more day to go after 52 weeks, that is 53 days will be there for the first day of a year. Coming to second day of a year, in this case that will be Wednesday. Now in leap year we have 52 weeks, 52 Wednesday and one more, that will make 53. In non-leap year we have 52 weeks, 52 Wednesday, but here we do not have extra weeks. So here there will be a difference, that is in leap year there will be 53 times the second day of the year, and in leap year there will be only 52 times. Now in this type of question, yeah, the year do matters. If there is year, then you can uniquely determine. If year is not there, then the answer will be cannot be determined. Coming to third, fourth, fifth, sixth and seventh, in all cases there will be 52 weeks, 52 days. Now hence we can conclude that the first day of a year in both the type of years, that is leap year and non-leap year, will come 53 times. The second day in leap year will come 53, in non-leap year will come 52, and the third day, fourth, fifth, sixth and seventh day of a year will always come 52 times. Now there can be some miscellaneous questions like the calendar of January will be same as in the month of the same year. For example, the calendar which is in January will be same as in the other month of the same year. So the calendar, when will the calendar in which month it will repeat same as January. For example, if 1st of January was Tuesday, then any other month of the same year will also have first day as a Tuesday, second Jan will be Wednesday, the other month will also have Wednesday. So the same calendar of January will repeat in which month. So here we'll have to go through all the 12 months, that is January, we have Feb, we have March, April, May, June, July, August, September, October, November and December. Now if we calculate the odd days, we have leap year and we have non-leap year. In both case we have 3, we have 1 and 0, 3, 3, 2, 2, we have 3, 3, 2, 2, 3, 3, 2, 3 and 2, 3. Now the question as it says that which month will have the same calendar as that of January. Now for this what we have to do is we have to add all the odd days, and where there will be a multiple of 7, the next month will be same as January. So we'll take the case of leap year first. Let's add. We have 3 plus 1 4 plus 3 7. Now here is multiple of 7, that means April should have the same calendar as that of January, but here there is a problem. January of 31st and April is of 30. Now 31st of Jan will not have the day in April, so this will contradict, so this will not be considered. We'll move ahead. That is 7 plus 2 9 plus 3 12. We have 12 plus 2 14. Now again a sum of 7, a multiple of 7, that means July. Yes, July also have 31 days and January also will have 31 days. So the month which will have the same calendar as that of January, that is July. So this is the way of finding it. We'll take an example of March. Now for March we'll take both the examples. We have 3 plus 2 5, 5 plus 3 we have 8, 8 plus 2 10, 10 plus 3 13, 13 plus 3 16, 16 plus 2 18, 18 plus 3 21. So from March to October we have 21, that is a multiple of 7. So in November it should repeat, but November is of 30 and March is of 31. So in the leap year it won't repeat. Let's check the example of a non-leap year. We'll have the same sum. So as March is of 31 and November is of 30, so calendar of March will not repeat. But we have seen the example of how a month gets repeat. We have to just calculate the odd days, and whenever it gets a multiple of 7, the immediate next month will be the answer. Coming to years, now year is a different. Coming to years we have 3 categories, that is first is leap year, second is non-leap year. But non-leap year is again divided in 2 categories, that is a non-leap year immediately followed by a leap year, and the other is a non-leap year is not followed by a leap year. For example, we have 2005 which is followed by 2004 immediately after a leap year, and in this we have 2006 which is not followed by a leap year. So we have 3 categories. Now in case of leap year it will repeat after every 28 years. So we have to take in mind that in leap year it will repeat after every 28 years. For non-leap year, in case where a non-leap year is not followed by leap year, it will repeat after 11 years, and for non-leap year which is immediately followed by leap year, it will repeat after 6 years. So we'll take an example. For example, 2015. Now it's 2015, that means it's a non-leap year which is not followed by a leap year, because 2014 was not a leap year. So in this case we'll add 11, the answer will be 2026. So we'll have to add 11 to have the same calendar as that of 2015. Next example, 2017. Now 2017 is followed by leap year, that is 2016. So in this we'll add 6, so it will be 2023. So leap year, the calendar of 2017 will repeat in 2023. 2016 will have 28, that is 2044. So this is the basic short trick. We do not have to go in depth for this because hardly this type of questions come, but when it comes it is based on 3 types: So we have just the answer, that is add 6 in case of a non-leap year followed immediately followed by leap year. In case of a leap year, add 28. In case of a non-leap year which is not followed by leap year, add 6. So this is the topic of calendar, and hope you will be able to understand it, or as the session is free, you can go any number of times from it. And I will be coming with more topics and more topics which are concerning other management exams and other entrance exam too. And if you want more topics which are based on logical reasoning or reading comprehension or any other verbal ability or maths or data interpretation, please go to www.catcorner.co.in. We have very successful and very pocket friendly products, and there are a lot of product with some free material to check, and if you like it you can purchase it because they are very pocket friendly. Because as a student, financial dependency is also important, and that will not affect you and will give you good quality study material with great mentors. Thank you.